Hello students, good afternoon, how are you? Our today's topic is wave motion. This chapter contributes one or two questions in NEET exam. And this chapter you need to practice more numerical problems only in this chapter, just like units and measurements. I told you, no, units and measurements, you need to practice more problems. This chapter also, you need to practice more number of problems. Properties of progressive waves, properties of stationary wave, vibrations of air columns, vibrations of stretched strings, beats. These 5 topics, problems, numerical problems, you need to practice. Come on, let us jump into problems. See the first problem, two open argon pipes of fundamental frequencies N1 and N2 are joined in series. There are two open pipes. Their fundamental frequencies are N1 and N2. Their lengths L1, L2 you take. The fundamental mode of vibration. In the fundamental mode of vibration, their frequencies are N1 and N2. Now these two are joined in series. Means these two open pipes of lengths L1, L2 join like this. Then you'll have again open pipe only. Again open pipe of length L1 plus L2 you will have. He's asking what is the fundamental frequency of this new air column in this new pipe. So what is this first pipe fundamental frequency N1, velocity of sound in air by 2L1. That means L1 will be V by 2N1. Similarly, this N2 will be V by 2L2. Means L2 is V by 2N2. Now come to this joined, the two pipes joined in this case, the fundamental frequency must be V by 2 into L1 plus L2, no, its length. Then in place of L1, I can write V by 2N1. And here V by 2N2, I can write V by 2 common here. That all V by 2, V by 2, V by 2, that gets cancelled. You will have 1 by N1 plus 1 by N2. N1 and 2 by N1 plus N2. Okay, let us now move into next problem. See the second one, an open pipe of length 80 centimeter has second harmonic frequency equal to fundamental frequency of closed argon pipe. The length of the closed pipe is open pipe length they gave, closed pipe length they are asking, and what is the condition given here? Second harmonic frequency of that open pipe is equal to fundamental frequency of closed pipe. For open pipe, what is fundamental frequency? V by 2L. Second harmonic means 2 times of V by 2L. That is second harmonic. Second harmonic means which is 2 times 2 fundamental frequency. You know? This second harmonic frequency of open pipe is equal to fundamental frequency of closed pipe. Closed pipe fundamental frequency V by 4L. LC I am writing closed pipe length. Here L0 I am writing open pipe. This second harmonic of open pipe is equal to fundamental of closed pipe. Equate them. V by 4LC is 2 into V by 2L0 and find LC. 4LC equal to L0. LC is L0 by 4. 20 centimeter, 80 by 4, 20 centimeter. Now in these pipes, another thing. Suppose there is an open pipe of length L. This open pipe fundamental frequency suppose 200 hertz given. This open pipe fundamental frequency 200 hertz given. Suppose the question is given like this. It is immersed in water so that 1/3 of length is inside water. Then what is the new fundamental frequency? 1/3 of length is immersed in water. What is the new fundamental frequency? Is asked. If this open pipe of length L is immersed in water so that 1/3 of its length is inside water, then how much length is outside? Means how much air column length is there? L minus L by 3. That is 2L by 3 air column is there. And this air column is enclosed in which pipe? Now this is closed pipe. No? Earlier it is open pipe. Now it is closed pipe. So what is the fundamental frequency of this air column enclosed in closed pipe of length 2L by 3? That is question. This 200 hertz is this complete open pipe fundamental frequency. Open pipe fundamental frequency V by 2L. This N 200 given. V by 2L is 200. Now what is the frequency of that air column in the closed pipe of length 2L by 3 is asking. Closed pipe fundamental frequency V by 4L. In place of L, I have to take 2L by 3. Then you will get 3 by 4 times of V by 2L. This V by 2L given as 200. 3 by 4 into 200. 150 hertz you will get. Like this also, questions can be given on this. Let us move into next problem. In Melde's experiment, when the tension in the string decreases by 0.009 kg weight, the number of loops changes from 4 to 5. The initial tension is dash. Melde's experiment means one stretched string will be there and weight hanger to create tension. We put weights here. This stretched string, one edge of this stretched string is attached to one vibrating tuning fork of some frequency n. This is Melde's experiment. Means this wire is made to vibrate with a frequency n. Now what you are doing, you are changing the tension. Again, frequency is that only. Means in this Melde's experiment, frequency of that stretched string is maintained constant. Now in this problem, you are changing the tension. Then the number of loops formed here changing. Here loops will form when stationary wave forms. The number of loops changed from 4 to 5, but frequency constant. Now what is the frequency of a stretched string? You can write like this. Now P by 2L into root T by mu. Mu linear density, T tension, P number of segments, number of loops formed is P. Here what you are changing? Tension. Because of that P changed. Remaining things same only now. Frequency constant, length of the wire constant, linear density, wire material same, wire thickness same wire. Na? So linear density constant, N constant, L constant, mu constant, variables are P and T. So you write like this, P into root T is a constant here. P into root T is a constant. That means P inversely proportional to root T. If you decrease tension, number of loops increase. So P1 by P2 is under root T2 by T1. He's asking find the initial tension. Initial tension T1 and the new tension decreased by 0.009 kg weight he gave now. So the new tension is T2 minus 0.009. P1, 4 loops, P2, 5 loops he gave. 4 by 5, 4 by 5. Now square both sides. 16 by 25 is equal to squaring. 4 by 5 square, 16 by 25 is equal to T2 minus 0.009 by, sorry, this is T1. T1 minus 0.009 by T1. Cross multiply that, find T1. Okay, let us move to next problem. See, these sound waves travel at 350 meter per second through warm air and at 3,500 meter per second through brass. The wavelength of the wave of 700 Hz frequency as it enters brass from warm air. Decreases by, increases by, this is asking. Means wavelength changed by how much is asking. In air, 350 meter per second is the velocity of wave. In brass, 3500 velocity of the wave. You know, out of all gases, velocity of sound is maximum in hydrogen gas. Out of all gases, velocity of sound is maximum in hydrogen gas. But out of all different media, that is solids, liquids, and gases. Out of all these three media, velocity of sound is maximum in solids, more in solids. Because of reason, which reason? Solids are highly elastic than these liquids and gases. Velocity of any progressive wave in any medium is root E by D. Formula is there now, where E is elastic, modulus D is density. Elastic property of solids is more. That's why velocity of sound is more in solids than in liquids and gases. So what is showing that only here velocity of sound in air 350, but in brass 3500. Whenever a wave travels from one medium to another medium, one medium to another medium, whenever wave travels, frequency of the wave remains constant. You know this. Velocity changes, wavelength changes. Velocity, if velocity increases, wavelength increases. If velocity decreases, wavelength also decreases. V proportional to lambda, frequency constant. So what I'm writing, frequency is V by lambda. Na? So wavelength of velocity in air by wavelength in air is equal to velocity of sound in brass by wavelength in brass. So I'm writing. What is asking here is wavelength in brass is how many times of wavelength in air? That is asked here. So lambda B is cross multiply this. VB by V air into lambda air. Find this VB 3500, V air 350 into lambda air 10 times. Wavelength increases by a factor of 10. Okay, next. The velocity of sound in air is doubled when the temperature is raised from 0 to some alpha degree centigrade. What is the value of alpha? 819. This is a common problem. Velocity of sound in gases is root gamma P by D, where gamma is ratio of specific heats of gas, P pressure, D density. This can also be written as root gamma RT by M. M molecular weight, gamma already you know, T absolute temperature. Newton-Laplace equation. Newton suggested that when longitudinal wave travels through a gas, the pressure, volume, they are changing, okay. Temperature remains constant. The changes are isothermal. Like that he suggested, but and gave a relation root p by d. Newton gave root p by d, which is not correct. That is corrected later by Laplace, and Laplace suggested the changes in gas, the pressure, volume, they will change, when longitudinal wave travels through gas. The change in pressure, volume, they are not isothermal, they are adiabatic. Sudden changes are always adiabatic. So, adiabatic bulk modulus is should take. Actually, what is velocity of sound in fluids? Formula root k by d, where k is bulk modulus. But gases will have isothermal bulk modulus and adiabatic bulk modulus. Newton suggested you should take isothermal bulk modulus, which is wrong. Laplace corrected it, you should take adiabatic bulk modulus. Adiabatic bulk modulus is gamma p, na? That formula is this. Now, he is giving here problem based on velocity of sound and temperature relation. Same gas, no? Gamma, M, same. V proportional to root T. Very easy this problem. V2 by V1 is root T2 by T1 root T2 by T1, 0 degrees centigrade means 273 Kelvin. This V2 by V1 is 2. V2 2 times of V1 given a double. Then squaring and cross multiplying, you will get T2 equal to 1092 Kelvin. From this, if you subtract 273, you will get centigrade temperature 8, 9, 10. And in this velocity of sound in gases based on this relation, another question also, this, suppose they gave velocity of sound in helium, velocity of sound in helium at a temperature T degree centigrade is equal to velocity of sound in hydrogen, suppose they give, in hydrogen at 27 degrees centigrade, then T is dash. Helium temperature is asking. So velocity of sound in helium at some T degree centigrade, velocity of sound in hydrogen at 27 degrees centigrade are equal. What is the T is asking. This, when you do it, be careful. One gas, monoatomic gas given, helium. Other gas, diatomic gas given. Gamma also different. Usually one mistake that what students do is, gamma also constant, they'll take and cancel that. Here, one is monoatomic, the other is diatomic. Gamma different. So, root gamma of helium or temperature of helium by molecular weight of helium is velocity of sound in helium is equal to root gamma of hydrogen or universal gas constant to temperature of hydrogen by molecular weight of hydrogen. Equate them. Both sides root cancel now. When you square it, then R cancel, R cancel. Then substitute. Gamma of helium, monoatomic gas, gamma ratio of specific heats 5/3. Temperature of helium, you want to find helium temperature T by molecular weight of helium. Substitute molecular weight of helium 4. Gamma of hydrogen, diatomic gas gamma, 7 by 5. Temperature of oxygen, 27 degrees, convert into Kelvin. 300, 273 plus 27 by molecular weight of hydrogen, 2. Simplify this, find T. Like this, don't forget gamma different. Suppose if both the gases are monoatomic or both are diatomic, then gamma cancel both sides. Okay, I'm moving into next problem. One more. Okay, one more. Wait. One more I want to tell you in this gases. Suppose a problem given like this. Velocity of sound in hydrogen at certain temperature and pressure. Velocity of sound in hydrogen at certain temperature and pressure is V naught. The velocity of sound in a mixture of hydrogen and oxygen mixed in 2:1 ratio by volume, their volumes ratio 2:1 is dash at same temperature and pressure. Okay, at same temperature pressure in the mixture of hydrogen and oxygen mixed in 2:1 by volume, what is velocity of sound? They are asking. So in this, V under root gamma P by D, if you take here first gas hydrogen, next mixture of hydrogen oxygen, both diatomic only. That means in both cases, gamma same, pressure same he gave. So V inversely proportional to root of density, you can write. That means velocity of sound in the mixture by velocity of sound in hydrogen is root of density of hydrogen by density of mixture, you can write. So you have to find the mixture density in terms of hydrogen density. So I'm writing that mixture density. Mixture density, any density, what is density? Mass by volume now. Mass by volume. So in this, there is hydrogen and oxygen. Mass of hydrogen, mass of oxygen by volume of hydrogen plus volume of oxygen. The density of mixture is equal to mass of hydrogen is volume of hydrogen into density of hydrogen. Volume of hydrogen in this ratio, how much? 2, 2:1, 2 given, 2 I'm substituting. Okay. 2 into density of hydrogen. This is volume of mass of hydrogen. Mass of oxygen is there. Again, volume of oxygen into density of oxygen, I have to write. Oxygen density 1 given in the ratio. 1 into oxygen density. 1 into oxygen density. Observe oxygen density. Oxygen density, how many times of hydrogen density? 16 times of hydrogen density by hydrogen volume plus oxygen volume 2 plus 1, 3. So 18 DH by 3 you are getting. So mixture density 6 times of hydrogen density you are getting. So here in place of this mixture density, 6 times of hydrogen density you substitute, you will get velocity of sound in mixture is velocity of sound in oxygen by root 6 you will get. So answer is velocity of sound in mixture is velocity of sound in hydrogen V naught by root 6. This is also important model in this. Next, next question 6. The equation of a stationary wave along a stretched string given. The separation between adjacent nodes. All are in centimeter here given. What is stationary wave equation given here? Y equal to 5 sine pi x by 3 cos 40 pi t given. What is the general form of this stationary wave equation? Y equal to 2a cos kx or sine kx cos omega t, like this, no? So in place of k, what is there here? Pi by 3 is there. First you have to find lambda here. K pi by 3 is there. So k means 2 pi by lambda, no? It is pi by 3 given, which implies lambda equal to 6 centimeter. Now, what is the distance between two adjacent nodes in a stationary wave? What is the distance between two adjacent nodes, node to node, node to node? Lambda by 2. No? Lambda 6 I got. Lambda by 2, 3. 3. Next. The path difference between two particles of sound wave is 50 centimeter. Path difference 50 centimeter given between two particles in the wave. And the phase difference between them 1.8 pi. 1.8 pi. If the speed of sound V is 340 meter per second, find the frequency of wave. Frequency means first giving velocity, frequency is asking means first lambda you should find wavelength. Phase difference between two particles and path difference relation 2 pi by lambda into path difference. No? Lambda is 2 pi by delta into x. 1.8. 1.8 means 9 by 5 now. 1.8 pi means 9 pi by 5. Substitute. 2 pi, 9 pi by 5. X in centimeter there here, x 50 centimeter, he gave 50 centimeter. 50 centimeter means half meter, na? Half meter. Find lambda value. 2 pi cancel. 5/9 meter lambda you will get. Now find frequency n v by lambda. V 340 given 340 by 5/9. Simplify that. Next, a progressive wave of frequency 500 Hz is traveling with a velocity distance between 2 points. Same delta equal to 2 pi by lambda into x. He is asking x here. Path difference is asking, phase difference given. Okay, path difference 60 degrees means pi by 3. 2 pi by lambda. What is lambda? V by n. V 360 meter per second only given SI unit. Frequency 500 given. So lambda 360 by 500 into x. Pi cancel. 1000 1 by 3 equal to 1000 by 360 into x. Find x. 0.12 you'll get 0.12. Next, two waves of amplitudes A1, A2 are superimposed. The ratio between maximum and minimum intensities of the resultant waves 9:4, A2, A1. Imax by I minimum. What is Imax by I minimum? Formula. Intensity proportional to square of amplitude. Intensity proportional to square of amplitude. No? Intensity. This type question you will get even in wave optics, Young's experiment. There also you'll get. Imax by I minimum root I1 plus root I2 by root I1 minus root I2 whole square. This you'll get now. And I proportional to A square means root I proportional to A. So this is A1 plus A2. Root I1 in place of root I1, A1 I can write, root I2, A2 I can write by A1 minus A2 whole square. I max by I minimum 9/4 given 9/4. So 9/4 is A1 plus A2 by A1 minus A2, A2 whole square. That is 3/2 equal to A1 plus A2 by A1 minus A2. Cross multiply, find A1 by A2. A2 by A1 is asking. See, A2 by A1 is not asking, not A1 by A2. Find that. Next, for a wave equation, y equal to 8 sine so and so. Find the phase difference in between two particles separated by 2 centimeter. This 2 centimeter is path difference. Path difference is asking phase difference. Lambda you have to find. See this 2 pi inside you take. This equation will become y equal to 8 sine 2 pi into 0.1. 0.2 pi x 2 pi into 2 minus 4 pi t. Now, this 0.2 pi must be k. So, k 2 pi by lambda is 0.2 pi, means 2 pi by 10. You will get lambda equal to 10 centimeter. Here see, unit centimeter given here. 10 centimeter you will get. So lambda 10 centimeter, this is 2 centimeter. So what you will get? 2 pi by 10 into 2. That is 2 pi by 5 radian. Here is giving answers in degrees. 2 by 5 into pi radian means 180 degrees now. 360 by 5, 72 I think. $72 degrees. Next. Yeah. A wire of length 2L is made by joining two wires A and B. This is one wire, this is another wire. Two different wires they are joined of same length same, for both length same, but different radii. One radius, this A radius given as R, B radius given as 2R. And they are made of same material, means their density same. It is vibrating at a frequency such that the joint of the two wires is a node. Here node is there, here node is there. Maybe here some loops form like this. Like this. Here node is there. Joint is a node. If the number of antinodes in wire A is P and in B Q, then P is to Q. Number of antinodes. This is antinode now, antinode. Number of antinodes is nothing but number of loops. Number of loops ratio is asking. So, what is the frequency formula? Number of loops segments by 2L into root T by mu. This is under root. This is P by 2L into under root T by this mass per unit length linear density can be written as area of cross section into density, mass per unit volume, this density, rho. Per square rho you can write, write like that because radius different there. You have to write it in terms of radius. Now see, whenever wave travels from one medium to another medium, frequency constant. So frequency constant here. For both the wires, frequency is same. And both are under same tension. Tension same here. And length same. So frequency, tension, length. These three are same for both the wires here. And density also. They are of same material. Density also same. So what are different? Number of loops and radius. That is different. Means P by root 1 by R square. All the remaining things constant now. Root R square is R. Means P by R. This value is same for both. So equate them. Number of loops in first wire by number of loops in second wire. P1 by P2 must be equal to R1 by R2. R1 by R2, R by 2R, 1 by 2. 1 is to 2. Okay, next. Going to next problem. One more point I want to discuss about strings. See this question, you see, logical it is. Suppose they give a stretched string is vibrating with some frequency. Suppose 100 hertz. 100 hertz with some points as antinodes. Some points are antinodes. Frequency 100 hertz. Some points on the wire are antinodes. Now what you will ask is, what is the next frequency for which the same points again become antinodes? Same point. Whichever is antinodes now, the same point should be antinodes again. What is the next frequency at which the same points again become antinodes? Like this, very important logical problem. For example, that 100 hertz frequency is fundamental frequency. Let us assume, just assumption. Okay, he has not given some points as antinodes, 100 hertz he gave. I am assuming that is fundamental frequency. One single loop will form in fundamental frequency. Then this middle point is antinode. Na? So what is the next frequency for which again this middle point only antinode is asking that. What is next to second harmonic? If you take this same wire of same length, if it vibrates in the form of two loops, that is second harmonic. This frequency will be 200 hertz now, 2 times 2 fundamental frequency. In this case, this middle point is not antinode, it is node here. Next to third harmonic, if you go, the same wire under same tension and same length, everything same, vibrates in the form of 3 loops of stationary wave. Now 3 loops like this. Third harmonic. In this case, frequency is 3 times to this. Now. That is 300 hertz. Now. Here you see this middle point which is antinode in first case, again becoming antinode. Means at what is the next frequency at which the same points again become antinodes? Means definitely that next frequency must be 3 times more than given frequency only. If this is given as 50 hertz, next frequency 150 hertz. If this is given as 200 hertz, next frequency at which same points again become antinodes is 600. 3 times only it is. Okay, I'm going to 12. Two waves with same amplitude, same frequency. First wave amplitude A, second wave amplitude also A. Superimpose. The ratio of resultant intensity when they arrive in phase to the resultant intensity when they arrive 90 degrees out of phase. Okay. What is resultant amplitude, resultant intensity? That relation, resultant amplitude. What is resultant amplitude? R, I will use R symbol. A1 square plus A2 square plus 2A1 A2 cos delta, where delta is the phase difference now. If they arrive in same phase, if they are interfering at same phase, means phase difference 0, cos 0, 1, then resultant amplitude will become A1 plus A2, that is 2A, A plus A, 2A. Resultant amplitude. Resultant intensity is some constant into amplitude square now. So some constant K into 4A square. That is resultant intensity. If they are at 90 degrees phase, when delta is 90 degrees, then cos 90 is 0. Then resultant amplitude, how much you will get? Root A square plus A square. That is root 2A. Then the resultant intensity K into resultant amplitude square. Root 2A square means 2Ka square. This is 4Ka square. That is 2Ka square. 2 is to 1. 2 is to 1. Next. Beats. Beats are produced by two sound sources of same amplitude and of nearly equal frequency. Nearly equal, not equal. Slightly different frequency. When sound waves of two slightly different frequencies undergo interference, then only beats are obtained. Nearly equal means slightly different their frequencies. The maximum intensity of beats will be dash that of one source. Means one source intensity I, other source intensity I. The maximum intensity. What is maximum intensity? Root I1 plus root I2 whole square. No? Root I1 is root I, root I, root I, root I, root I, root I, 2 root I whole square. That is 4I, means maximum intensity is 4 times of intensity of any one source. 4 times. Okay, next. The equation of traveling wave, progressive wave equation given. The ratio of maximum particle velocity to the velocity of wave propagation. Maximum particle velocity. Particles make simple harmonic motion in wave. Maximum particle velocity A omega. And if wave equation is y equal to A sine omega t plus or minus kx, if this is wave equation, omega 2 pi n, k 2 pi by lambda. Omega by k equal to, if you divide these two, you will get n lambda. That is velocity of wave. So wave velocity omega by k is asking the ratio of maximum particle velocity to wave velocity. These two ratio is asking. Means A omega by k is asking omega cancel ka. A 60 k 6 is there now here, kx in place of k 6 is there. This is 60, this is 6. And distance unit microns given, micrometer. Means this amplitude is 60 into 10 power minus 6 meter. Amplitude, micron given now there. A, k is 6. K is a constant, no? It is propagation constant of the wave. 6 it is. So substitute them, find Ka. Find 16 to 60 into 10 power minus 6 into k value 6 into 10 power minus 6 micron given. No? Find this 5 into 36 into 10 power 11, something like that you are getting. Okay. Next. Wave equation, two waves undergo interference. This is one wave. This is another wave. These two undergoing interference and producing beats. How many beats? Number of beats per second. And the intensity ratio between waxing and waning. Means maximum, minimum intensity ratio. We have to find what is the beat frequency. N1 difference, N2 now. The difference of the frequencies of the two waves now, number of beats per second. Find it. Omega 1, 710 pi. 2 pi N1 is 710 pi. Pi cancel. 710 by 2. 355 hertz you will get. Like that, the other one is, second one, 2 pi N2 is 702 pi. Pi cancel. N2 702 by 2. 351 you will get. So one wave frequency is 355, other is 351. Difference of these two is 4. So number of beats 4, 4, 4. A, C, two options are there. Next, intensity ratio. Intensity ratio. Maximum intensity. I max and I minimum. I max, I minimum, their ratio. What is maximum amplitude? Maximum amplitude, A max. If these two ways produce constructive interference, maximum amplitude you'll get, na? That is A1 plus A2, 4 plus 3, 7, 49 is there. C, option C. A minimum amplitude when they undergo destructive interference, amplitude minimum na A1 minus A2, 4 minus 3, 1. So I max by I minimum is A max by A minimum whole square. 49 is to 1. Third option. Next. Two waves given, two waves. If the frequency and amplitude of the resultant wave remain equal, these two waves have same amplitude. The resultant wave amplitude also same is giving. When two vectors of same magnitude act at an angle 120 degrees, then only their resultant is also equal to either of them. One vector is of magnitude A. Another vector is also of magnitude A. Second vector magnitude also A. If these two vectors act at 120 degrees, then their resultant will be also equal to A only. A few days back, this case I told you this. This is that case only. First wave amplitude A, second also A, their resultant also A, means their phase difference is 120. Resultant amplitude root A1 square plus A2 square plus 2A1 A2 cos delta. This is A, this is A2 also A into A, cos 120 minus 1 by 2. 2 to cancel, you'll get resultant amplitude A only you'll get if it is 120. So their phase difference is 120 degrees, 2 pi by 3. Next. This is very easy. Equation of progressive wave given. Velocity of wave is asking. Omega by k is velocity of wave. This is in the progressive wave formula. Sine in brackets you have kx minus omega t, omega 400. K is 20. X and Y meters. So directly meters only 20 meter per second. Easy. Next. Two sound waves of wavelengths 5 and 6 meter produce 30 beats in 3 seconds. Find the velocity. wavelength of the wave, lambda V by N, N is V by lambda. Lambda less means frequency more. First wave frequency more, N1 more. Here, N1 is more. So, number of beats, N1 minus N2 equal to, this is the number of beats per unit time, beat frequency. 30 beats per 3 seconds means per 1 second, 30 by 3, 10. V by lambda 1, 5. N2, V by lambda 2, 6 is 10. From this, find V. 6V minus 5V. 6V minus 5V. V. 5 into 6. 30. V equal to 300. And in these beats, I want to tell you one more. I want to discuss in these beats. Suppose they may give a tuning fork and a string are in unison. If the tension in string increased by 4%, then they produce 5 or 6 some beats they will give. 6 I am giving. The frequency of tuning fork is like this, they can give bits. So this, how to solve this? They are in unison initially, means their frequencies are equal. Initially, tuning fork, stretched string have equal frequency. So there is a tuning fork, its frequency N. There is a stretched string under a tension T. Its frequency also N only now. Unison means resonance, unison means frequency is equal. Now what you are doing? Tuning fork frequency same as it is. Tension in this string increased. When tension increases, frequency increases in the string. Frequency increased by 4%. Suppose its frequency will become N plus delta N. Frequency will increase now, N plus delta N, after tension increased by 4%. So this N plus delta N different now. Now you'll get beats. Their difference, what is N plus delta N difference? Delta N. The difference only in a number of beats, that is given 6. Delta N 6. Now N is asking. Now what you do is, for a stretched string, N proportional to root T. That is T to the power of half, which implies delta N by N into 100 is equal to half into delta T by T into 100. This delta T by T into 100 percentage change in tension 4 given. So substitute 4 there. Delta N by N into 100 is 4. This delta n is 6. Sorry, 4 into half I have to write, no? This half into 4. This delta n is 6. Substitute 6 here. Find n. Tuning fork frequency you'll get 300 you'll get. Like this is also important model in beats problem. Beats shaded string combination. Okay, time over. All of us students practice more problems in this chapter, units and measurements. So this chapter, these are problems you need to practice. All the best.